So you see this question now. The force is acting in the same direction with the distance. So for that reason, the moment will be zero. There will be no moments there. So this one is your classwork. They give me this, give me the distance, and you know the SI unit should be in meter. So solve this one for me. Put the answer in the comment section. Also solve this one for me. Put the answer in the comment section. So we are solving this. So they say find the value of x in this. So put these two, the answers in my comment section. So let's analyze this number 13. So they say in the figure above, Mn is a light uniform meter pivoted at O. The 80 cm mark, a load of 20 kg is suspended on the room. The 30 cm mark, the road is kept in equilibrium by a string RP fixed at P and anchored to the room at R, 20 cm. Find the value of 2. So this is what we are looking for. So to solve this, we'll employ the principles of moment and the equilibrium of forces. So I'll draw a free body diagram. This force here is not at 90. I need to take it at 90. If I take it to x, it becomes in the same direction with the distance. So the force at x, I don't need to resolve it. So I'll try to take this now to y-axis so that I have force that is at 90 degrees. So for that reason, my free body diagram will be this one. So I have it's free body diagram, but I normally put this to make you understand. Then I have 10 cm here. Then I have 20 cm here. So if I resolve this to y-axis, it will become TRP, tension on R and P, sine 30 degrees. Then I have my pivots. It's at 80 cm mark. Then I have my N. So the next thing is to ask myself, they said you remember meter rule is 100 cm. Meter rule is 100 cm. So notice the total length here. That is this meter rule. The total length of everything is going to be 100. So I'll now say, if this is 10, that means from this point to this point is 10 cm. Then if this is 20, that means if I have 10, I have another 10 here. 10 cm. If I get into this one. So if this is 80, you know it's drawing, and I've resolved this force to the y component. So if this is 80, sorry, from here, if this is 80 cm, it simply means that from 20 to 80 should be 30, 40, that's 20 to 30, to 40, to 50, to 60, to 70, then to 80. So the gap between these two should be 60 cm. That's the sentence saying, yes, sir. The sentence saying 80 minus 20, 60 cm. So that means that what is remaining here after this point, from this point to this point, should be 20 cm. So the next thing is to convert all the cm to meter. So, and I know that cm to meter is division by 100. So if I do each one divided by like 10 divided by 100, I should be having 0.1. So this is 0.1 in meter. 0.1 in meter. 0.6 in meter. 0.2 in meter. 0.8 in meter. 0.2 in meter. Alright, so this now we can now with this we can now start solving. So there's 20 kg here, and this is mass. There's force acting down, so it will be times 10 force of gravity. So this one is actually 200 in Newton. The force here, 200 Newton. Yes. So the next thing is to ask myself, this force now, everything should be directed towards the pivots. Assuming it's stop, we are looking for here. We can see which part did they ask us, but for this case, direct everything towards the pivots. So this force going towards the pivot. Remember, clockwise is this way. While anti-clockwise is this way. Clockwise and clockwise. So if this force goes this way, you see it's anti-clockwise because it's going to be moving this way, moving this way, moving this way, which is the center of this. So for my anti-clockwise force, I put 200 Newton. And for my clockwise force, let me check. If this one is directed towards this pivot, this one now goes towards this pivot, this force goes so that it will be moving in this direction, and this is the direction of clockwise. So I have TRP sine 30 degrees clockwise. And the next thing is to remember that moment, this is the principle of moment we are doing, and the principle of moment says that anti-clockwise must equal clockwise. Then we also remember that moment is force times perpendicular distance. So we need to sum up the distances. So notice from this point now is at 10 centimeters. Then going towards these pivots, we'll come across all these distances. So it's the same thing as saying 10 from here to here is 10. Yes, if it's on the meter rule, from here to here is 10. Then from this point to this point is 60. That is 10, 20 plus 60 to give you that 8. So plus 60, so 10. From this point to this point is 10. Then 10 plus 60, 70. 70. So before you get to that pivot, so 70 meter. Yes, sorry, 70 cm, which is the sentence. Yes, Shebi, yes, 70 cm, which is the sentence saying 0.7 meter. Yes. .7 meter. Then for this force, from this point, remember we took the question, we analyzed it here. So for this particular force, from this point to this point to the pivot, that's what we are checking. The distance from the force to the pivot is going to be 60, which is 60 cm. That is 0.6 in meter. So the next thing to do is to apply the calculation. So I will now say force times S, which is 200 times 0.7. And for the clockwise, is going to be TRP sine 30 times 0.6. So which will give you 0.6 TRP, tension in RP sine 30. So for applying this our principle now, and now come and say anti-clockwise 200 times 0.7. This is 1/4 in Newton. Yes, Newton. Okay, Newton meter, because the unit of moment is Newton meter, equals to 0.6 TRP sine 30 degrees. So, and this one is, yes, we can now say divide both sides by 0.6. And this will cancel. So 114 divided by 0.6 is equals to 233.33 is equals to TRP, tension in RP, sine 30 degrees. So we can also go again by saying divide both sides by sine 30 degrees. So this will cancel this. So you see that we are left with sine 30 is now 0.5. So this is the same thing as 0.5. So we can say 233.33 divided by 0.5. So we now have tension in RP to be equals to 466.66. Okay, and this is going to be in the TRP. First of all, this is in Newton meter, and this one is in meter. Should be? Yes. 0.6 meter. Yes, 0.6 meter. And this one is everything here. Sorry, this one is in meter. Everything here is in Newton. Yes. This one, everything here was in Newton. So TRP in Newton. So when you do it, some of my students, okay, this will cancel this. Yes. So the sine 30. Okay, so I'm left with just, yes, and tension, the unit of tension is in Newton. So this is the same thing as saying tension in RP is equals to 467, approximately 467 Newton. So this is my answer. So this T that they're asking me to find is actually going to be 467. So still solve it to get your own answer, and we are correct. If you don't get our answer, you are wrong. We are the correct one. So we have the correct answer. So this is our T, and that T is tension in RP. Okay, they said the diagram below show the positions of a cone, which one can be described as neutral. So the one that is neutral, this one is in stable equilibrium. Y is in stable equilibrium. X is in unstable. So Z is in neutral equilibrium. Okay, let's now analyze this. They gave us, they gave us this. Then I say we should calculate the torque about A, calculate the torque about B, calculate the couple. Okay, so let me analyze, let me draw the free body diagram first. Okay, this is the free body diagram. I've drawn it. So this one is the same thing as saying 0.5 meter. So the length is 5 meter. That is, they are saying that we should take the total length of this. Yes, to be 5 meters, Shebi. Yes, that's what they are saying. Total length, we should take it to be 5 meters. So if that is the case, and they're telling us that this thing runs from this point to this point, and it's 3 meters. So if that is the case, that means that everything, and they're telling us that here, this point is 0.5 meter. That means that what is remaining here is going to be 1.5. 1.5 plus 0.5 is 2. 1.5 plus 0.5 is 2, yes. So we've analyzed it. So they are now asking us to find the torque about A. So finding torque about A simply means rotating the forces, these two forces here. And notice that these two forces is what we call couple. They are equal in magnitude but opposite in direction. So rotating this about A. And remember that in circular motion, when you are going this way, which is counterclockwise, it is assumed you are doing positive. You are going in positive direction. Why when you are going this way, it's assumed that is clockwise, assumed that it's negative in angular displacement. Why? Somebody wants to ask me why. You remember that time we did our origin. We normally say this is 0, this is 90, this is 180, this is 270, so this is 360. So you see that this is the normal way that this quadrant and origin go is going like the anti-clockwise direction, and this is the positive. So once you are going against this movement, it's assumed that you are going in negative, and going against this is clockwise. So you need to know that. But in some cases, you need to know that it doesn't matter. When you always remember that signs, those signs doesn't matter if you always do your solving by doing anti-clockwise equals to clockwise, so that you don't even bother about negative and positive. So always use this. This is the manual approach for it. So alright, let's go. So let's try to find the tug about A. So tug about A, simply rotate this force now going towards A. As I'm going towards A now, you see clockwise or anti-clockwise. Remember that clockwise is this way, anti-clockwise is this way. So you see that this thing now will go this way. It's clockwise. So this is CW. So this force F1, and clockwise moment must be equal to anti-clockwise moment. So I will say F1 is clockwise. Now let me rotate this force now about A to go to A. So you see that it's moving this way, and this way is anti-clockwise. So anti-clockwise, no, F2 is anti-clockwise about A. Anti-clockwise about A. So what I will now do is to say, okay, I've gotten that. So I will now say ACW must be equals to CW. So I will now say this is the F1 is 100 Newton. Then as he moves this way, as this one moves this way, what distance did they cover? 3 meters. So sorry, F1 is 100, both of them are 100. So this one moves this way about A, going, see it, if you like, don't open your eyes, moving this way about A, moving this way. Assuming they said about B, I'll move this way. So about A, that's what I'm looking. Remember, calculate the tug about A, and tug is the measure of the force, product of force and distance of circular motion or in circular motion. So see, as he moves this way, it's covering 3 meters times 3. This one that moved anti-clockwise, as he moved the way this way, is covering this 0.5 and 3 meters. So it's covering times 3.5. So equals to, yes. So if I check it very well now, I see that what I have is, let me be sure, yes, I have, yes, going this way 3 meters, then coming this way. So, and we remember what tug is. Tug is equals to force times R. So let's try to solve. So I do 100 times 3.5 is equals to 350. Then 100 times 3 is equals to 300. So notice that I have 350 and I have 300. Okay, let's say I have okay, so now that I have this now, 350 is equals to 300. So I can now say 350 minus 300 is equals to 0. So this is going to give me 50 equals to 0. Okay, and if that be the case, notice, remember, it's the tug I'm finding. So the tug about A, so equals to 0, or yes, so it's equals to, I can choose to say this 50 is equals to A. Yes, it's an equation. Yes, it's an equation, so we don't have to manipulate it. So it's an equation. So this shows me that the tug about A is 50. The tug about A is 50. Now let me do about B. If you like, don't understand this thing. Since this is equals to this, I'll make it an equation which is equals to 0, which means that what I have here, total force here, is 50, which is equals to 0. And I'm saying, since I'm taking it about A, this is more logical. It's going to be that the tug about A, since it's rotating, moving up forces around circle means tug. So that's why I say that the tug about A is 50. Now let me get the tug about B. So tug about B will simply be moving this force now towards B. Notice that if I'm moving this force now towards B, it is going in anti-clockwise, because anti-clockwise is the one that goes this way. So So you see that this one will still turn to come this way. So I'll now have, so see, so if I'm doing now, remember the question said calculate the torque about B. So to calculate the torque about B, simply moving this force now about B is anti-clockwise. So I will say in that case F1 about B, F1 will be anti-clockwise. F2 will be equals to, let's check. If F2 is going about B, see. So F2 now about B will be going this way. And this is clockwise, so clockwise. So about B. About B. So what I now need to do is to remember that F1 is 100, F2 is 100, but they are moving in the opposite direction. So which we call, these two forces are called couple. Force is equal in magnitude, but in non-parallel, moving in different direction, having different effects. Example, when you on your tap and you off it, first they stop. Alright, couple. Now let's go. The next thing is to check the distance. From this point that we're moving, we'll move this way. We'll come across 0.5 for F1. Then we'll come across 1.5. Nice seeing it. So F1 will simply be F1 times 2. That is 0.5 plus, that is 0.5 plus 1.5, which is 2. That is for F2, which is the sentence as saying 100 times 2. Yes, 2. Yes, 2. Yes. There's 2 meter. Then let's go for F2. So for F2, if this moves this way, see that the only distance is covered on is 1.5. So F2 will be times 1.5, which is equals to 100 times 1.5. So we now say ACW is equals to CW. So that means 100 times 2 is 200. So I have 200 Newton meter is equals to clockwise 150 times 100 times 1.5. So I have F2 to be 150 Newton meter. So they are in the same unit. So this is going to be 200 Newton meter minus, if this crossover, 150 Newton meter equals to 0. So you see that this is going to be the sentence saying 50 Newton meter equals to 0. And that means 50 Newton meter is equals to the torque about B. So you need to know that. Now notice that whichever direction you move it to, because the forces are equal, 100, 100. If you move it about A, it gives you 50. If you move it about B, it still gives you 50. That's what it means. And if I don't even want to do that, if I don't want to stress myself, I'll just come here and say, this force, notice that these two forces, 100 and 100, they are acting about this point, and the length given to me here is 50 cm, which is 0.5. Is it not true? So I can say 100 each of the forces. I come and say F times R, which is 0.5. So I come and say 100 times 0.5. 100 times 0.5. I get 50. And this thing that I just did here now is also the couple, because couple is equals to force times length. Even this is a couple, this is the couple I'm getting, not really the torque. I've gotten the torque. So to get the couple is what deals with length. So assuming I just did force times the length, I get the couple. So you need to know that it's not hard. You just need to watch this video over and over and think about what we've just done. Then let's move to the next one. Then they say calculate the couple. Yes, calculate the couple. So that's how you calculate the couple. Couple equals to force times length. So 100, that is each of the force, any of the force, F1 F1 couple is going to be 100 times the length, which is 0.5. So we give you 50. If you do it for the other one, the same thing. Alright, let's solve this question. And say we should prove from this diagram that FL sine theta. Prove tog equals FL sine theta from this diagram. So what I'll just do is to say, looking at the diagram, I'll just say tog first of all from this will be equals to, this body is rotating. As it's rotating, you have force times the distance that is covering, and even this L, but as it's covering the distance it will rotate. So I will now say sine theta, naturally there's an angle here, is equals to sine theta from this rotation will be, this side is facing this, opposite is D all over, but SOHCAHTOA, opposite over hypotenuse. So if this becomes my D, that means that this becomes my hypotenuse, because the sides the angle is sitting on is always the adjacent. So this becomes my L. So if you make this subject of the formula, you now have L sine theta. So that means that this is the same thing as saying F, replace D with L sine theta. So tog equals to FR or FL sine theta. So proved. Alright, so let's go to the next one. I'm asked to find the value. I'm asked to find the value of tog about A. So if I look at this very well, I'll see that it's looking like the other one. So what I'll just say is, this is 90 degrees, and I have 30 degrees here, and I have Fy. So I'll ask myself, if this is 30, if I have something like this and I have 30 degrees, me, I naturally I don't like using, I always advise my students, don't use the angle made with the vertical. Find a way to get it to the horizontal. So you see 90, everything here is 90. 90 minus this 30 gives me that this is 60 degrees. This is the angle I'm using. And notice that this angle here, this is my 60 degrees. So that means that if I have this now this way, and I have this way, and I have this to be 30 degrees, it simply means that this one is 60 degrees. So I now have my F. You can actually do cos 30, but I don't like using that angle with the vertical, because sin 60 and cos 30, they are the same thing. But I don't like using that angle with the vertical. This is A. Yes. So I will now say, using the same principle, once I have my angle here, I will say if this is the angle, this becomes my adjacent. The side facing it becomes my opposite. This side automatically becomes my hypotenuse. Somebody will say, but it's not looking like hypotenuse. See what first determines is the angle where it's facing, which is the opposite. So I will now say sine theta here will be equals to opposite D over hypotenuse L. So D will now be equals to L sine theta. And sine theta I'm using here is going to be 60 degrees. Then then L is 2, so D equals to, so, and I know that tog is equals to force times rotating distance, and here they not put R, they put D. So I will now say T is equals to F L sine theta. So T is equals to F, then L is 2 sine 60. Now what is my F? Notice that the F given to me here, is 20 Newton. Is it not true? This is 20 Newton given to me. 20 Newton. And this is when it's on the y-axis. This is already on y-axis, 20. So if I want to get this my force at this angle, now. Force at this angle is going to be when I take this now to this axis, opening this now. So I'll actually have, if I push this now, I actually have, okay. First, on the vertical axis has already been given. Yes. Okay, see here. See, they did not give me this. They gave me Fy when this is at 90 degrees. Yeah? And notice that this angle that I have here, this angle I have here on this force, yes, we actually judge this now. We actually judge this like this, so that this everything here is 90 and it makes with this. Yes, so this is actually 20. Yes, it's for the vertical. It's actually 20 times 2 sine 60 degrees. So 40 sine 60 degrees. So 40 sine 60. T is equals to 34.64 Newton. So this is my answer. What wanted to confuse us is we wanted to say, since this F is this way, let's try to resolve it. Yes, let's try to resolve it. So, but if we want to do it that way, we can actually say, okay, yes, okay, this one that we are using now, this we can actually say, let's resolve this. And if we want to resolve this now, it will now be in such a way that we have 20 Newton here, Shebi. Then we have this. Then we have this. Then we have this 20 Newton. Then we have 30 degrees, Shebi. 30 degrees. So we have this side. Then down here, yes, down here, yes, everything here is our length, which is, yes, which is 22 meter. Sorry. So if we do it properly, to get this particular, this is what we want to get, the hypotenuse. This is the resultant. That will give us the F there. Sorry. So this one, see, this thing that we did here is for this force. So it's not proper. And if we are to use that force, what we should use here is cos. Cos. Somebody will want to see, some of my students will be running mad now. So please, let's maintain our sign and whatever. But what we want to do is to find the force. The F is not given there. That F is not given. So if we find that F, we use our sign. So let's maintain everything. So I now have, if I want to get this now, I have this, I have this. So using Pythagoras, I will now say r square is equals to s square 2 square plus 20 square. So that r square is equals to 20 times 20. So 4 plus 400. Then r will now be equals to square root of 404. Yes, so square root of 404 will give me r to be equals to 20.0997. So this is what I'm getting. And notice that the arrow I've gotten here is the force. So this force here is not 20 Newton. This force here is actually R, which is equals to 20.0997. Approximately the same 20. But we just try to make sure that we are very correct. So T is equals to 20.0997. So times 2 sine 60 degrees. So that this becomes 20.0997 times 2. So we have 40.1994 4 sine 60. So T will be equals to 40.1994 sine 60. So 34.81 Newton. This is correct, not 34.64. This is what it should be. This is how to go about it. We are very correct. This is what it should be. So we don't have to use that force. We don't have to use that force. So what we actually did is to remember that this, if this is here, it should be parallel to what we have here. Parallel forces. So now when we project this, so that's what we did. We said if this is here, and we have this, and then we have this one, then we have this. This is the force we are looking for. So if we project this and this, they are parallel. So when they meet, now remember that this side is 2, then this side is 20. That means this side should be 20. So you don't have the R. That's what we did. Then we got our R, which is the force. Then when we got it, we now substituted, and we have our answer. So we are correct. See, it's not a smooth road. Good number of you, when you see maybe we are doing this and we have to go through a lot of things, you get confused and you give up. That simply shows that you don't understand how this knowledge is. It's something that really requires authenticity and, or should I say, you understanding how it should be done, not something that has been just brought out and at the end of the day it becomes too easy. So go about playing it again, then it will make more sense to you. So this one, the last one here, the second to the last one, they said